Hello, everybody, and thank you for joining us for this traceable webinar on managing API-driven applications. If you'll please be patient for just a few more seconds, we are going to hang out and allow people to get into the room and get situated. We will begin in about 30 seconds. Thank you. Alrighty, let's kick this off. So thank you everyone for joining us. Good afternoon, good evening, maybe good morning, wherever you are joining us from. We're glad to have you with us. Welcome to today's webinar. We are going to be talking about managing API-driven applications. My name is Dan Gordon, and I lead the technical evangelism team here at Traceable AI, and I'm happy to be your host today. We've got some great knowledge to share with you, but before we do that, I have a couple of housekeeping items. Today's session is being recorded, and it will be available to you after the session through BrightTalk. We welcome questions in the webinar control panel. Click on the QA button and enter your questions there. We do have time set aside to answer those towards the end of the session. With that out of the way, I'm excited to welcome today's speaker, Renata Budko. Renata is Traceable AI's head of product. She's got her own intro slide in her deck, so I'm just going to hand it over to you, Renata, and let you take it away.
Thank you, Dan. Good to be here. And today, I wanted to talk to people who are not engineers, people like me who are product managers, perhaps engineers with other venues, security engineers, compliance, risk managers. Maybe you're not a developer, but in today's world, API-driven applications is where we are. And to make business decisions about these applications, you need to understand ins and outs of this world. I'm happy to share my experiences with you. As a product manager, I have been and seen API applications for many years. In my current role as head of product at Traceable, we help companies protect applications and deliver API observability and security. So also a lot of hands-on and real-world experience in and around APIs. And I have access to information both about the API technology and the API market and how the two influence each other. And that is exactly what my talk is about today. If you are in software industry, if you're in infrastructure industry, SaaS is probably what you live and breathe. And this is just a little bit of a confirmation in terms of the hands-on numbers based on a survey done by IDG about a year ago. They looked at what the situation is currently, and they also have predictions for what's going to happen in the near future. So based on what they found out and what the audience been telling them, software as a service delivery model is already prevalent, but it will pretty much be the only model. 95% of all the software will be delivered as SaaS. And SaaS, in most cases, means API-driven applications. And even if you approach this from the infrastructure standpoint, for the non-cloud applications, even for those, 70% of those will be in SaaS model. But for the applications that are in hybrid or private or public cloud, API-driven SaaS model, PaaS model is what you end up in delivering. So what is it that you need to know about APIs and what kind of APIs are out there? Of course, the thing that we are most interested in is what we're getting paid for. how do we deliver our applications? In delivering value with API is the focus of everything SaaS and PaaS. You may think that your application is a mobile application or something that gets used in a browser or an IoT application. And that's what you've been talking about when you're talking to your customers. But if you turn around into your own engineering team, all those applications are powered by API and driven by API. In terms of mobile devices, that iPhone or Android communicates to the logic on the backend server via APIs. Browsers, single page applications, all of that is API driven. Machine to machine communications, APIs, also API driven. And even within your application, there is a strong move from monolithic applications to distributed applications based on containers, based on services that are internally powered by container-to-container API communications. So APIs are very central to how your SaaS application is designed, operated, and delivered to the end user. The second category we're going to touch on today are APIs that help you access the data. And here we are looking at several different categories, but particularly interesting are categories that help you host and process data as a service. Good examples here are Snowflake, which helps you to implement some of the processing and machine learning in a hosted environment. Cloudera has been doing API and data hosting for many years. So APIs that essentially help you store, access, and process data on the back end is a very important category, which has its own challenges because of data privacy issues. And then last but not least, interestingly, it overlaps with the first one, access to value-added API-based services. We are moving very fast today, and the reason why we are able to move this fast is because we stand on the shoulders of the giants. We don't need to implement from scratch things like GPS on a map, payments, weather widgets. Any number of other services is already built in and available for us via external third-party APIs. So whether it makes sense and when it makes sense and which APIs and services we want to use here is the other topic of today's conversation. So first things first, when you with your engineering team start developing a new SaaS application, you need to make a decision on what API protocol your application will be based on. And honestly, where we are today, you have probably made this decision already, but we'll have a little bit of a discussion on the differences between this. Probably the most prevalent today is the REST protocol. That is based on structured data. Essentially, that means that the key of what the data is, for example, the key may be street address, and the value of that address, 555 Market Street, San Francisco. The data in a structured way like this gets sent from your mobile application or browser or whatever application your user is interacting with. The data gets sent to your backend application in that JSON format. Similar but a little bit older, you might have seen that perhaps in 2015, is a format called SOAP. And it's also structured data format, but instead of JSON, it is based on the XML structure. And this format was very popular when we still talked about internet service providers and telecoms. So if you were one of the early API users, you still might have some SOAP in your infrastructure. And then opposite of that, going diagonally to the left, is a brand new darling of the new APIs. This protocol is called GraphQL. And it's an efficient protocol that allows the client to request not the entire set of data, but only specific subset that they are really interested in. So if you're an Uber application, for example, and you are driving in San Francisco, you may want to request all the addresses with the condition that San Francisco is the city within the data field that we talked about. And then the last protocol that I wanted to mention today is gRPC. This protocol is primarily used for real-time communications, particularly for internal communications, RPC, remote procedure call. If you are using APIs to connect one microservice to the next within your environment, your engineers are probably using gRPC as a protocol for that. So what do you select as an API protocol? There are several concerns that you need to keep in mind here when deciding on this. One is what clients are using and what are the clients capable of understanding. In many cases, there is a backward compatibility issue, and perhaps you need to be compatible with a mobile application that's been around for a long time, and all you can do is support a REST API. So how intelligent your edge is important that way. And also, mobile applications may have a lot more logic than, say, simple browser applications. So you need to understand that. The other consideration, especially in the case of GraphQL, is whether your developers are comfortable putting in a gateway, which is like a translator between the protocol that your edge supports and the protocol that your backend talks. Then another consideration in terms of the design pattern is whether you send a lot of data. And at that point, the amount of data and the performance that you need to implement, as well as the security considerations for what happens at the control plane, as in when you add a new user, for example, or when you add a new entity, and how much data you need to send. A good example of this separation is the case of Netflix. A data plane is streaming your movie, lots of data, large media, very strong concerns for latency, and as opposed to managing payments for the movies or payments for subscriptions. Different security considerations, different transaction rate, but a lot more controls are required. And in that same Netflix example is where we want what we want to do with the payment APIs and the control plane is quite important in terms of how it's authenticated, how it's managed, and additional compensating controls that you want to implement on the control plane during the runtime. And this is probably one of the areas that Traceable deals with the most in terms of observability, change management, test coverage, and runtime protections for the APIs that can really make or break your business and expose your company to risks. On the other side of this consideration, the streaming of that Netflix movie, in terms of the data plane, the requirements here are quite a bit different. What you need to consider there in many cases is how well that API can perform. If there are a lot of data, you need to consider how many concurrent sessions that API needs to service. And when the API services it, where is it going to get the data to service the clients? How much data there is it types of data that are individual messages, maybe short strings, as also large multimedia files that you need to deliver. And of course, last but not least, connectivity management is important. Are you counting on reliable connection, or do you need to deal with lossy connections, interruptions, buffering, things like that? In summary, for the APIs that you use to deliver the value, the things to consider and the impacts on your product are based on the choice. Client support. When defining Edge APIs, what are the clients that you plan to support with this API? Scalability. How many clients? What kind of load the clients are going to put through, and how you're going to orchestrate that scalability. And security. Well-defined APIs like REST, like SOAP, like GraphQL, they are helpful in terms of compatibility, but because they're well-defined, that same property can be exploited by malicious users, by hackers, to understand the logic of your internal API, internal application, and exploit it. So additional controls for security and compensating controls for the design and security design needs to be followed here. So then, for third-party APIs, why would you want to use those? First of all, it's time to market. Features that you can't develop, don't know how to develop, or don't care to develop, can now be brought in to your application and bring value at a drop of a hat. In many cases, there is compliant consideration. Stripe has built its whole business on taking the credit card payment out of the hands of the individual shops, and that way, as a store owner, you don't need to be concerned about complying with PCI regulations. This is extremely important if your business is still small and you are looking to scale gradually. In many cases, some services require a fairly high threshold of initial implementation, even if your volume is small. By using third-party APIs for that service, you are paying as you go. In many cases, as a fast-growing business, it is easier to understand and budget for services that you consume on a per API call basis, as opposed to investing and scaling right away for the lifetime of the user. Technical considerations when you are consuming third-party APIs are fairly strict, though. One thing you need to make sure is that whatever your application is designed as is compatible with how the third-party application is serviced and the APIs that are allowed on that side. Outside of the use of the gateways, as we mentioned previously, API protocols and especially the APIs that are implemented as libraries need to be compatible and scalable with your application itself. A big consideration here is backward compatibility. You need to invest in monitoring, understanding, and updating your own applications when a third-party API changes. In some cases, especially if you're a smaller startup, the API can change with little notice, and that can impact your business. So contingency plans and resources for managing compatibility need to be allocated and accounted for. And then last but not least is performance of a third-party API. If you're a driving application and your GPS API and map API is not keeping up, you can see that your drivers are getting stuck. From the product planning, the impact here is to see what is important to you, and see if the faster value and the other benefits of not having to invest in the infrastructure, if that's valuable and important to you. The other positive impact here is, of course, you can pay as you scale, and as you grow, you pay more, but you don't need to pay for what you don't use. The negative impact is compatibility and versioning. We are all moving very fast. Your API supplier and service supplier is also moving very fast. But you need to make sure that your customer experience and your customer impact is accounted for. So there is some extra resources that's negative in using third-party APIs. So internal APIs, what about those? Using internal APIs is probably not a choice. It's not a question of whether you will use internal APIs. It's a little bit more of a question of when. In our own experience, most of our customers have some applications that are still monolithic applications, but most of our customers also have plans to move to API-driven and distributed applications. So distributed applications are, of course, using internal APIs to communicate to backends, to send messages between different microservices, to horizontally scale those applications that they're delivering. So internal APIs are pretty much the lifeblood of the modern applications. In many of considerations on why you want this are even similar to using external third-party APIs. A faster time to market, reuse of open source code, infrastructure as a service, all of those are the reasons to use internal APIs. And the cherry on top, these distributed architectures that use internal APIs also help you make your distributed teams more efficient. Now in the COVID times, we are probably more than ever cognizant of the fact that people are working in smaller groups, people are working remotely. So our ability to outline a specific contained piece of work that eventually gets implemented as a microservice is very helpful for distributed teams. But then once you start assembling those microservices together, this is where internal APIs come in. And the APIs, when you use APIs, it forces the well-defined interactions, and that means that your code becomes almost self-documented with use of some additional tools, of course. And that also helps with automation and defining test coverage. In terms of how you're going to use those internal APIs, there are many different approaches here. Two of the more popular ones today, especially in the world of containers and Kubernetes, is the use of the API gateways, and in the case of Kubernetes, service meshes like Istio. One of the considerations that's probably new for internal APIs that you didn't have in monolithic applications is more focused on authentication and authorization for service-to-service APIs. So then from the business and product standpoint, what to pay attention to? The positive of using internal APIs: each microservices can stay on its own development path, so it's great for the distributed teams. And you can focus on just those microservices that bring big added value, and every change doesn't impact everything else. So you end up moving a lot faster. Transparency and self-documentation along with test coverage is a big positive. And it also has the added impact for the product managers to be able to better understand the external impact of specific functions, methods, and microservices. On the downside, this approach, use of internal APIs and designing the applications from the ground up to be distributed, does require a different approach from engineering and somewhat different approach from the product management standpoint as well. It's API first, so that means your definition of the application needs to be different for this approach to work well. In conclusion, I wanted to invite you to embrace this API economy, and hopefully we all can join the crowds and cohorts of extremely successful API companies. In the last 5 years, the companies like Stripe, that as API first and only APIs, I've increased the valuation from $3.6 billion to over $22 billion. Twilio, AWS as a public cloud, of course, grew over 7 times in just what they collect in revenues. A lot of smaller companies, Auth0 recently got acquired. Zapier works as a connector between different APIs. All of those companies have become increasingly successful in the last few years, and so can you. And this is probably one of the proudest moments in our own history as well. One of traceable customers, Marquette, which is an API-first company in the startup, in financial technology business, just this month, went IPO with huge success, was listed twice as a CNCB disruptor, and was valued at $60 billion. In the very first day of trading, increased the valuation by 13%. So great job, Marquette, and Marquette joins a long list of the successful companies that focus specifically on the API and that make API applications the centerpiece of the go-to-market journey. And with that, I would welcome questions. You are free to post questions in Q&A window, or of course you can tweet questions to Traceable account after this presentation as well.
Great. Thank you very much, Renata, for sharing all this great information about APIs and what they are, and especially how we should be considering when we start working with them. Really great stuff. Thank you for sharing that. Yes, so as Renata mentioned, it's time for a Q&A portion of the webinar. So let's see, we'll look what we've got coming in, and do feel free, as mentioned, to drop any questions in the QA section of the webinar controls. So let's see, first question. Developers are telling me that we need an API gateway to use APIs in our application. What do those do, and do I really need one? So API gateway.
Thank you, Dan. API gateways are an interesting beast. Many of you have probably heard of gateways like Apigee or Kong. They're very helpful for companies that want to deliver their services via exclusively APIs. Gateways have features like metering and billing and external authentication that help companies make this API delivery or even API marketplaces easier for other software developers to consume. There are definitely benefits of using API gateways within your own application as well. Some of the modern gateways, like Kong, who is a traceable partner, are designed to be used within the application. And if you are designing a brand new application from scratch, using an API gateway may be an easy shortcut for you to not having to implement certain validations or certain authentications. They're definitely not required to make your application API driven or to rely on the APIs. So as I like to say, there are more than 9 methods to skin the cat. API gateways is a good one, but it's not required.
Great, thanks for that thorough answer. So let's see, next question regarding API security, which was mentioned in the talk. Would the same WAF that protects our web, wouldn't the same WAF, sorry, that protects our web applications also protect our APIs? So isn't it all just HTTP? Why do I need something else?
It is an interesting question, and thank you for that. It's a bit of a softball. I have been working with WAFs and web application firewalls for probably the good part of the last 5 years. Very familiar with many of them. All the simpler web applications firewalls, if you think through to maybe AWS WAF or Cloudflare is a popular offering, which, by the way, is also a great market success. They have always focused on the applications that are in browser. Those applications, especially multi-page applications, have quite a bit of different challenges than APIs themselves. So all the WAFs may not even be able to parse the APIs or create a lot of false positives within the APIs. And then in addition, APIs have their own security challenges. In fact, the open source organization focusing on web security, OWASP, has just last year published a brand new guidance for the risks that are specific to APIs, OWASP Top 10 for APIs. So if you're delivering value via APIs, or if your application uses APIs as an API-driven application for internal APIs, your old WAF is probably not going to protect you. You need something that is API-specific.
Yep, thanks. Yeah, I think it's we kind of have a canary in the coal mine going on, right? With all these breaches that we've seen with big companies. Granted, they're not all API, but there are quite a few API breaches, and these are major companies with investments in security. I think that's telling us something about the existing solutions and how effective they are.
Very good point, in. Yeah, a recent Facebook breach, for example, is a good example. Of why the existing WAF could not see into the API for addressing the multi-image situation in business accounts.
Yeah, great example. So another question from the audience. I heard API specifications can be auto-generated from code. Is that good enough? Does this provide good change control?
Great questions. And I did mention that APIs were self-documented when you used internal APIs. It is and it isn't. If they were all self-documented, wouldn't that be wonderful? Because we all want code to be self-documenting, have enough comments, explain the successful use cases, and error handling. So that's a very, very interesting situation that way. For API-driven applications, it's easier. And there are some specialized tools that would help you go through the code and identify APIs as they are defined and output that into a standardized specification format like OpenAPI spec or Swagger. So there is definitely more capacity and more facilities for generating documentation from code in the API world versus when you implement monolithic applications. At the same time, what is implemented is not always there, and it's not always well defined. If your application has not been implemented as an API first, or if you perhaps are using third-party microservices where you either don't have access to the code, or those API definitions have not been well formed, that specification that gets auto-documented may not be complete. So always a good idea to auto-document, have it self-document, but also compare with an API specification that you actually see in the runtime. So I would not recommend using it for change control, but as a first step for documenting what you have going, definitely great tool.
That makes a lot of sense. I think, yeah, definitely. Like if you have shadow APIs, by definition, you don't have a definition, right? So
by definition, you don't have a definition.
It's a shadow API. You don't know about it, right? So you probably don't have it documented either. Okay, great. We have another question here about applications. So are applications based on APIs? Do they have a different software lifecycle versus apps that are not distributed?
They do. Distributed applications have a lifecycle that is based on the lifecycle of individual modules. So hopefully each microservice gets implemented separately, gets tested separately, and potentially gets retired separately. So for APIs, it is advisable that you also have this automated, considering that all of these things can have somewhat different life cycles. So central CI/CD, continuous integration, and continuous deployment becomes ever more important in the case of the API-driven delivery. And at the same time, I have mentioned compatibility issues for when you're a consumer of third-party API applications. So being on the other end of this, if you are delivering the value as a service via APIs, I ask you, for the sake of the community, to please be very transparent about the life cycle of your APIs. It will help us all.
That's a very good request. I guess this is a follow-up question to that, which is, okay, so given all that, what's the best way to test APIs? We kind of have a sense of how to do that with non-distributed apps, right?
Mm-hmm. It is a very interesting question, and with APIs, you kind of want to not just do the end-to-end testing, and not just do the unit testing that exercises the code, but also test the APIs themselves, especially internal APIs, as they get initiated in the service-to-service communications. So having a spec is extremely helpful in that case for even generating traffic based on your Open API spec. And that can be something that you have used from the self-documenting, as well as something that was observed in real time. So definitely a very interesting topic. Some tools you can use even from OWASP. Zap allows you to load Open API spec and start testing there. So many interesting strategies that are unique to the API-driven applications.
Very good. Makes a lot of sense. Let's see. So there's no more questions. We'll give it a few more seconds if anyone wants to put in any last questions. And while we're doing that, I will go ahead and thank Renata for sharing your wisdom with us. And okay, I think we'll call it. All right, this concludes this webinar. Again, thank you, Renata, for sharing your wisdom with us. And thank you, everyone on the call for joining us. And we hope you'll join us again. Have a good rest of your day or evening.
Thank you for hosting, Dan.
Very happy to.